So we're going to start off by looking at number 13. Now the reason I'm not having you guys do 7 through 12 is because that's just identification. And if I wanted you guys to be able to identify those certain angles separately, I could, but the fact is that doing all the other problems, you're going to have to be able to identify them anyway. Put your phone away, please. Okay, so we start off with angles 1, 2, and 5. So right away, we can sit there and say that the measure of angle 2, how does the measure of angle 2 relate to the measure of 105? What are they? They're alternate interior angles. So, and we learned that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Right, so that means they're the same. So we sit there and we can right off the bat put there. So now we want to look at how does the 105 relate to angle 1? Huh? No, they're not corresponding. So when we're talking about corresponding, each time a transversal hits a line, it creates 4 angles, right? So in that scenario up there, I like to think of them as top right, top left, bottom left. And 1 would be bottom right, 2 would be bottom left. What is 105? Top right. And so in order for them to be corresponding, they need to be the same. Top right, bottom right, bottom right. And there we have a top right and bottom right. Okay, remember the 4 angle pairs or relationships we talked about were corresponding, alternate interior, alternate exterior, and same side interior. Now, when we talk about same side and alternating, that is on sides of the transversal. Interior and exterior relate to the parallel lines. So what is that going to be? Are they alternating interior? Okay, well, let's first. Are 1 and 105, are they interior or exterior? Interior, right? Because they're between our parallel lines. Same side or alternating?
Same side.
So same side interior. Same side interior angles are?
Congruent.
No. I love the dedication though. Well, they can be. They don't have to be. They are? Anyone?
Supplementary.
Supplementary. Connor for the win. So they're equal to 180 degrees. Then we need to use our good friend, subtraction property of equality. Subtract 105 from both sides. And we get the answer that the measure of angle 1 equals 180. 75. Okay? Does that make sense to everybody? Yeah? Okay, what's not making sense? Keep in mind, again, interior between the parallel lines. And that's true even if you have parallel lines like this. We're going to assume those are parallel. How do I know they're parallel? Little arrows, see? They're parallel. Can't argue with the arrows. Don't even try. I see you trying to argue back there, Chris. Knock it off. In between the 2 arrows are parallel, right? So that's interior, exterior. If we're talking about alternating or same side, we're talking about which side of the transversal they're on. Okay? So that would be how we look at number 13. Now I want everyone to do number 15 really quickly. It looks harder, but if you just really kind of take a breath, realize what it's asking, it's not that bad. So I'm going to give you guys about 3 minutes to work on that. Okay, so I hope you guys were all working on this.
Yeah.
So what we want to do now is we want to actually look at the relationship. And we want to start off by remembering that when two parallel lines are cut by a transversal, corresponding angles are
Congruent.
congruent, right? So do we have any corresponding angles there?
Yes.
Huh? What are they?
118 and X.
118 and x, right? So if 118 and x are congruent, then 118 is equal to x. Now, we also know that, just like on the last problem, x and then that angle formed by y in 25 degrees are same-side interior angles. That means that they add up to 180 degrees because they're supplementary. Since we already figured out that x equals 118 degrees, we can plug it in, so we get 118 plus 25 plus y equals 180. We add the 118 and the 25 together, so we get 143 plus y equals 180. And then again, going right back to our dear, dear friend, subtraction property of equality. We subtract 143 from both sides. And we get y equals 37 degrees. Boom. And then go ahead and highlight our answers, because why would we want a teacher? That's 2. Headphones up, please. Why would we want a teacher who has 150 tests to grade to have to go looking for our answers? Because you're evil? Yeah. That actually is my belief as well. So how many of you guys got 118 and 37? Let me see hands. Okay, good job. How many of you guys didn't, but now understand how I got it? Okay, how many of you didn't and don't know how I got it? How many of you didn't do it and don't know how I got it? Okay, if you are in either of those last 2 categories, test is tomorrow. Make sure you come in, see me after school, lunch, before school. Okay? Because again, did I do this poll yesterday? How many of you guys have worked with me individually, one-on-one? Now I want everyone to flip the page, and we're going to look at okay, so the proving lines parallel and the parallel and perpendicular lines. So the proving lines parallel really has to do with, is just kind of the opposite of this. Go back a little bit, go there. Okay, because it's really just taking it from a different point of view. So we start off, if we say, if 2 lines are parallel, then cut by a transversal, then corresponding angles are congruent, right? And then we also used the interior angle postulate here. We said if 2 angles are congruent, or if 2 angles are I'm going to start that one over. 2 lines are parallel, cut by a transversal, then the alternate or same side interior angles are supplementary. Okay, and so we sat there and we went, okay, let's do the math. We did the math, and we got 118 and 37. Now, if we look at the difference between what that is asking us to do and what proving lines parallel has to do, all proving lines parallel, instead of saying these lines are parallel, therefore, what are the angle measures? We're saying, what do these angle measures have to be in order for these lines to be parallel? Well, what would we figure out? We'd figure out, well, if they're going to be parallel, then corresponding angles have to be congruent. If they're going to be parallel, then same-side interior angles have to be supplementary, right? And we do the exact same math. So it depends on kind of where you're starting from. Make sense? Okay, so we're actually not going to do another problem for 3.3. We're going to jump down to section 3.4 on page 208. Now, we did a bunch of these in class, but if we're looking at number 22, we have B, C, and D, right? And so we know that we basically, when we're talking there, we have three different postulates that we're dealing with. Or theorems, rather. We're dealing with the parallel line theorem, the perpendicular line theorem, and the perpendicular transversal theorem. The parallel line theorem, and you guys should all have these in your notes, in your rules, postulates, and theorem bank. Your parallel line theorem says that if two lines are parallel to the same line, then they're parallel to each other. And that's A is parallel to B, B is parallel to C, therefore A is parallel to C. We did a bunch of these in class. We then have the perpendicular line theorem. Perpendicular line theorem says if two lines are perpendicular to the same line, then they're parallel to each other. And again, that's kind of like the proving lines parallel, right? Because if we have two lines crossed by a transversal and they form equal corresponding angles, then they're going to be parallel. And finally, we have the perpendicular transversal theorem, and that says if a line is perpendicular to one of two parallel lines, it's perpendicular to both. Here we're given B, C, and D. And we're being told that C is perpendicular to B, and D is perpendicular to B. So how are C and D going to be related? Parallel, right. And they're parallel because of the perpendicular line theorem. And that says if two lines are perpendicular to the same line, they're parallel to each other. Halloween really took its toll on you guys, didn't it? So, Natalie, I saw you and your crew over at the park yesterday. Okay. So that brings us to triangles. And again, when we're dealing with triangles, we have two basic theorems. We have our interior or triangle angle sum theorem, which is just fun to say. Everyone say it, triangle angle sum theorem.
Triangle angle sum.
See, right? It's like you're stuttering almost. So triangle angle sum theorem. And that says all the interior angles of a triangle have to equal 180. So that means if you're given a triangle and all the angles inside have like x's in them, you just add them all up. Solve for x, plug the x back in, done. The exterior angle theorem is a little bit more tricky, but still pretty useful. So what is really helpful with the exterior angle theorem, if we were to look and try and find x and y here, is we know that 135 plus y equals 180 degrees. Because an exterior angle, by its definition, is the measure of an exterior angle. An exterior angle, by its definition, is an angle formed by the side of the triangle and the extension of an adjacent side. So that's a straight line. So it's a linear pair. It's always an exterior angle is always going to form a linear pair with that interior angle right next to it. And what are linear pairs? What else are that? What are they? They're supplementary, exactly. So linear pairs always add up to 180 degrees. So again, we have 135 plus y equals 180. We subtract 135 from both sides, and we get y equals 45. Now, I just happen to remember our right triangle, one of the theorems we had on right triangles, and that was that the sum of the non-right angles are complementary. It's a complementary angle theorem. So I can figure out that x plus 45 equals 90. I subtract 45 from both sides, and I get x equals 45. Now, I actually write 90 up there, but don't worry. I'll come back and fix it later. So I also know there are three ways to do this. I know that 90 plus x plus y equals 180 degrees. And so that's using the triangle angle sum theorem, right? I add up all of the interior angles, and I get 180 degrees. Now, because I know that y equals 45, I can write it as 90 plus 45 plus x equals 180. 90 plus 45 is 135. 180 minus 135 is 45 degrees. So again, that gets me x equals 45 degrees. Finally, I can use the exterior angle theorem. I can sit there and say I know that the exterior angle is equal to the two remote interior angles, their sum. So I can go that 90 plus x equals 135. I subtract 90 from both sides. 135 minus 90 is 45. And go back. And again, notice that I did it three different ways and all got the same answer. So that either means it's the right answer or I'm consistently bad. Okay? More likely that it's the right answer. Normally, if I get three wrong answers, there'll be three different wrong answers. Very rare that you do it three different ways and get the same wrong answer three times. Okay? Questions on that? Okay, now we spent, the next section is constructing parallel and perpendicular lines. Okay, so you will have to construct a set of parallel lines. You will have to construct either a square, a rectangle, or a triangle given specific side lengths. Remember, this is construction, which means that you get to use a compass and a straight edge, you don't get to measure them out. All no. So if you do not feel, we spent 4 days on this. I want to give you guys a little bit of time to get started on the review today. That way, if you have questions, you can ask me. But if you do not feel comfortable with the constructions, either ask me in class today, come by at lunch, after school, before school tomorrow. If you need help with those. Huh? Yeah. Today at lunch, today after school, tomorrow before school. But I don't want to deal with the passing out of all the bullseyes and all that, because that will just take up the rest of the time. Also, in dealing with, so moving on, we're now on page 210, and we're dealing with parallel and perpendicular lines. Now, both of those, when we're dealing with graphing parallel and perpendicular lines, slope is key. So it's important to remember that slope is rise over run, change in y over change in x, and the formula for it is y2 minus y1 over x2 minus x1. And again, so the three things you need to know, and again, we spent all day yesterday reviewing this. Three things you need to know. The slope of parallel lines are what? They're equal to each other, right? The slope of parallel lines are equal to each other, and that's how you know they're parallel. Take your headphones off, please. You know that lines are parallel because their slopes are equal and their intercepts are different. And yes, I realize I put the slope of perpendicular lines. I'll change that. Don't worry about it. So the slope of perpendicular lines are negative reciprocals, right? So they're the negative reciprocals. When you multiply them together, you get what?
Negative 1.
Negative 1. The product of the slopes of perpendicular lines are negative 1. So up there I just put the example. So if the slope of 1 is a over b, what is the slope of a line perpendicular to that? Negative b over a, right? We flip it and change the sign. So if I had negative 4/3 as the slope of a line, what would the slope of a line perpendicular to that be?
3/4.
3/4, positive 3/4. Flip it, change the sign. right? So if I have negative 3 over 4, I flip it over. So I have 4/3, and then I change the sign. Make sense? So all of that has to do, so if I give you an equation such as, let's say, y equals 3x minus 7, and I want the equation of the line that's perpendicular and goes through the point 1, 6. Best way to do that, Vance? Come on. Yeah, go ahead. Best way to do that is, I know I have my two forms, right? I have my slope-intercept form. Great if I'm given slope and the intercept. And I also have my point-slope form. Which should I use here? What does perpendicular relate to? The slope or the intercept? Slope. So if I know that the slope of the original line is 3, what's the slope of the perpendicular line? Negative 1 over 3. So I know my slope is negative 1 over 3. I know it goes through the point 1, 6. So I can write my equation as y minus, this is x1, y1, 6 equals negative 1/3 times x minus 1. And that would be the equation of the line. You don't need to put it into slope-intercept form. You can just leave it like that. That is a viable and valid line equation. It's the point-slope form. When we're working with lines that we already know the equations to, slope-intercept is going to be probably easier to work with. But when we're given a point and a slope, easiest way to do that is to put it into the point-slope form. That's kind of what it's made for. Questions? Okay? Get going if you have anything. If you're working on it tonight, don't know how to do a problem, drop me an email.